Look, for as long as we've been staring out at the ocean, somebody, somewhere, has been thinking, I wonder what's down there. It's just human nature. We see a big, mysterious body of water. Our first instinct is to figure out how to get to the bottom of it. This isn't some new idea, a dream that goes back centuries. Long before we had the tools or the know-how, people were sketching out contraptions telling stories about traveling underwater, the stuff of legends and wild imagination, a world hidden from view, full of strange creatures, maybe even lost treasure. The surface was known, the depths? That was the final frontier. Right here on our own planet. Thinkers like Leonardo da Vinci doodling designs for underwater ships 15th century, he saw chaos before the thing was built. That tells you something. Alright, let's get down to brass tacks. Dreaming is one thing, but building is another. The first person to actually build a working submersible wasn't some famous inventor you've heard of. He was a Dutch guy named Cornelis Drebbel. He was working for the King of England in the 1620s. This wasn't a sleek metal machine, it was basically a wooden rowboat, wrapped in greased leather to make it waterproof. He attached oars that stuck out through flexible leather seals. Those seals let his crew row while underwater. It sounds ridiculous, but here's the kicker. It worked. He supposedly took it down about 15 feet in the River Thames, staying under for a few hours. The real challenge wasn't just staying dry, it was breathing. Drebbel's solution was a trade secret. The story goes he had a chemical process to refresh the air. He likely used saltpeter. Heated, it would release oxygen. Crude and dangerous, but a breakthrough. He was doing a job no one had done before, figuring it out as he went. Fast forward to the American Revolution. The colonists are desperate. They're up against the most powerful navy in the world, the British Royal Navy. When you're the underdog, you have to get creative. Enter David Bushnell, a student from Yale who had a radical idea. He designed and built what is arguably the world's first combat submarine. He called it the Turtle. Diagram close-up, 18th century engineering marvel, one-man vessel, shaped like a weird, upright egg, made of oak beams bound with iron, just big enough for a single operator to sit inside. Interior, operator working hand cranks and foot pedals. Operating the Turtle was a dirty job if there ever was one. The operator had to manage everything at once. One hand crank moved a propeller to push it forward. Another crank moved a different propeller to make it go up or down. Foot pedals worked the rudder for steering. Mission briefing. Get close to a British warship. Use a hand drill to attach a mine to its hull. Then get away before the mine's timer ran out. By the time of the American Civil War, submarine technology had taken a few more steps forward, but it was still a terrifyingly dangerous business. The Confederacy, much like the American colonists, was outmatched at sea and looking for any advantage it could get. This desperation led to the creation of the H.L. Hunley. This wasn't some wooden egg, it was a repurposed steam boiler, a long, narrow iron tube that looked like a cigar. It was powered by a crew of 8 men sitting shoulder to shoulder on a narrow bench, turning a long crankshaft that was connected to a propeller. It was dark, cramped, and a total death trap. The job of the Hunley crew was arguably one of the worst jobs in military history. The conditions inside were brutal. The air was foul, the only light came from a single candle that would flicker and die when the oxygen ran low, and the physical exertion was immense. And the submarine had a nasty habit of sinking. When World War I broke out, the submarine finally came of age. The technology had leaped forward. We're not talking hand-cranked contraptions anymore. Diesel-electric boats, diesel engines to cruise on the surface, charged massive batteries, shut down the diesels to disappear, switched to quiet electric motors underwater, decent range and speed, a truly viable weapon. Germany embraced it. U-boats, undersea boot, changed naval warfare. Naval traditionalists saw them as a gimmick. They were wrong. September 1914, U-9 finds 3 British armored cruisers. In under an hour, U-9 sank all 3. Over 1,400 killed. Brutal wake-up call. Submarines became predators of the fleet. Battleships threatened by a weapon that struck unseen. Germany, facing a tight British blockade, turned the tables. They declared unrestricted submarine warfare. If World War I was the submarine's debut, then World War II was definitely its main event. All the major naval powers had built bigger, faster, more capable submarine fleets. The Germans, once again, led the way with their U-boats. This time around, they refined their tactics under the leadership of Admiral Karl Donitz. Instead of single U-boats hunting alone, he organized them into wolf packs. A scout U-boat would find an Allied convoy, radio its position. Other U-boats would swarm in for a coordinated nighttime attack on the surface. Their speed and small silhouette made them hard to spot. It was, honestly, a devastatingly effective strategy. The Battle of the Atlantic was the longest continuous military campaign of the war. For the first few years, the U-boat wolf packs were winning. They sank thousands of Allied ships. On the other side of the world, in the Pacific, the United States Navy was waging its own submarine campaign against Japan. The American submarine force, known as the Silent Service, had a rough start with faulty torpedoes that often failed to explode. But once they fixed that problem, they became incredibly lethal. After World War II, everyone knew what the next big step had to be. The biggest weakness of the submarine was its reliance on diesel engines' batteries. It wasn't a true fish, it was more like a creature that could hold its breath for a while. It needed an engine that didn't require air. The answer was nuclear power. And the man who championed this vision in the United States was an abrasive, brilliant, and relentless admiral named Hyman G. Rickover. He fought the Navy bureaucracy tooth and nail to make it happen, and in 1954 his vision became a reality with the launch of the USS Nautilus. The Nautilus changed the game completely. It was the world's first nuclear-powered submarine. It carried a small nuclear reactor on board that used nuclear fission to create intense heat. This heat boiled water into high-pressure steam which spun a turbine to generate electricity and turn the propeller. The best part? A nuclear reactor doesn't need any oxygen. This meant the Nautilus could stay submerged for as long as its crew had food and water. For most of their history, submarines were built for one reason: to sink other things. But today, while their military role is still crucial, submarines are doing a lot of other dirty jobs that don't involve torpedoes. One of the biggest fields is scientific research. We know more about the surface of the moon than we do about the bottom of our own oceans. Manned submersibles. Unmanned submersibles are our primary tools for exploring this deep, dark world. They take scientists down to study bizarre ecosystems around hydrothermal vents. They discover new species of life. They map the ocean floor in incredible detail. Take a vehicle like Alvin, for example. It's a deep ocean research submersible that's been in service for decades. This isn't a military boat, it's a floating laboratory. It has carried scientists on thousands of dives, famously exploring the wreck of the Titanic, studying the geology of the Mid-Atlantic Ridge.